all, we are going to see what is satellite communication. Satellite communication is nothing but a general communication from Earth station to the space. It having the satellite having payload, bus, and it having the transponder to transmit the data signals from the transmitter to the receiver. Based on altitude, it is divided. First one is LEO. Second one is GEO. Third one is MEO. Fourth one is HEO. We know that LEO is a low Earth orbit and geostationary Earth orbit, and this is a medium Earth orbit and high eccentric Earth orbit. These are having the, based on the altitude, the satellite communication having the orbit structure. We must know that the satellite is placed must in the geostationary Earth orbit for the communication. Based on that, LEO, GEO, MEO and HEO, it having the altitude range of 19, and that GEO having the altitude range of 36, and it having the altitude range of 36 to 48, and it having the altitude range of 48, and it having the rotational speed based on the minutes and seconds also. It having 90 minutes it took off to rotate, and it having to rotate 24 minutes, and it having to rotate 36 minutes, and it also took to rotate for 36 minutes. Based on that, the satellite rotation, the satellite is placed just on the geostationary Earth orbit. It having the rotational speed of 24 minutes it having to rotate, and it have to rotate for 100 seconds, 100 rotations. That is called as a gyroscopic rotation also. Then we move on to the laws. What are the laws the satellite communication is based on? First one is Kepler's law. The Kepler's having 3 laws. Kepler's first law, Kepler's second law, Kepler's third law. The Kepler's first law is based on the path. What is the path range is we must place the satellite on the orbitical path in the geostationary Earth orbit. The Kepler's first law states that the path followed by a satellite is equal to the mean distance between them. It having the formula of E equal to root of a squared minus b squared by a. And we based on the Kepler's second law, it is based on the equal area of intervals. This law states that for equal area of intervals, the satellite must be given the distance, mean distance is equal to the difference between them. So then we move on to Kepler's third law. The Kepler's third law is equal to the square of the mean distance is equal to cube of the statistical area. A cube equal to mu by n squared. Here we can know that by the law states that the mean distance is equal to the cube of area and inversely proportional to the distance between the satellite. Then we move on to Newton's law. The satellite communication is based on 2 laws. One is Kepler's law and the other one is Newton's law. We have already seen the Kepler's law and we move on to the Newton's law. Newton's first law. Newton's second law. Newton's third law. For the first Newton's law, it states that for every particle is in the state of rest, it should be in the rest condition unless or until an unbalanced force is acting on it. If the force is acting on that particle, the particle is under the condition of a moving condition unless or until any unbalanced force acting on that particle until the particle is in the moving condition also. Then we move on to the Newton's second law. It having to note that we all must know the Newton's second law is F equal to ma. The force is acting and getting on that by the application of the acceleration and the product of the mass also. When we get the force in the second law, it is the product of mass and acceleration only. If the acceleration is passed on that any particle or an object, there we get a force on the object. Then we move on to Newton's third law. We all know about the Newton's third law, very familiar. For every action, there is an equal and opposite reaction. For that condition, if any force acting on that object, it having to remove and it have to result in an opposite reaction in an unidirectional condition. It having the opposite direction also. So we can get the opposite reaction in the opposite direction also. Then we move on to orbital parameters. Orbital parameters are having the first one is sub-satellite path. Second one is apogee. Third one is perigee. Fourth one is line of upsides. First, we must see these four important points. What is sub-satellite path? It is known that the path just below the earth station of the orbit, we can call it as a sub-satellite path. What is mean by apogee? It is the closest path near the earth station, and perigee is not nothing but a longest distance or farthest distance from the earth station. The line of upsides is called, the difference between this perigee and apogee is called the line of upsides. Then we move on to the retrograde orbit and prograde orbit. What is mean by the prograde orbit? It having the point of upsides and it having to note that below the earth station. And the retrograde orbit is also having the above the earth station, which having the rotation of this prograde orbit is rotated on the degree of 0 to 90 degree, and this rotation at the point degree of 90 degree to 180 degree. And we move on to what is sub-satellite point, and we move on to the geostationary and stationary orbit and station keeping. These parameters are based on that positioning also. Then we move on to what is sub-satellite path. First, the satellite is located in the sub-satellite path. Then we move on to the satellite in the orbital position. We must keep that satellite on the geostationary earth orbit, and that condition only we have to communicate from the transmitter to the receiver. Then we move on to station keeping. What is station keeping? The satellite must be placed in a geostationary earth orbit. In condition of having the 36,000 kilometers having the altitude range, it not work on that distance, because the geostationary earth orbit is located in the area of 24,000 kilometers only. If the orbit is having above the 24,000 to 36,000 kilometer altitude, it does not keeping the station keeping of the satellite at that condition. Then we move on to stationary and geostationary fact. What is stationary? The satellite should be placed in a station at the geostationary part with having the rotational speed of 0 to 90 degree from the direction of eastward from the north. The satellite rotate to the eastward from the north. And this is the direction. The satellite should communicate towards the eastward from the north direction with having the plane of horizontal plane. So we must having the satellite should be placed in an orbit of to measure at the eastward, and except of the stationary orbit other than the geostationary, what are the satellite paths should not be kept in that stationary part. It is called as a non-geostationary part. The satellite should be called as a non-geostationary. And one important point we have to note that the limit of visibility. All the satellites should having the limits of visibility, because the satellite should be sent through the earth station. From earth station to the space we have the limit of visibility and the angle also. Next condition is the important condition is limit of visibility. The limit of visibility having the two conditions. One is azimuthal angle. Next one is elevation angle. As I already told that azimuthal angle is the conversion of measuring the electrical signals or radio wave signals from satellite to eastward. The satellite communicate towards the eastward from the north side, and the elevation is angle the uplook side angle, uplooker angle. The elevation angle is when we are in the earth station we have to look at the upper angle also, so it is called as an elevation angle. Then we move on to the launching procedure. How we want to satellite launching should be happen. When the satellite is first, we have to transfer the satellite from the earth station to the geostationary earth orbit. The geostationary earth orbit having the thrust which having the which already sent, we have to send the jet also. In that jet we have the important mass and the thrust faculties, and all are loaded in that jet, and we have to send the satellite to the geostationary earth condition. We have to place it on the geostationary earth orbit. Then we have two conditions. One is space transportation system. Space transportation. And the next one is expandable launch vehicle. These two conditions are having the transportation of the satellite. When we transport or we have to send that satellite by these two conditions. First one is space transportation vehicle. We have to send the satellite from earth station to the space by this STV. This STV is having to transfer the satellite to the transfer orbit, that is Hoffman orbits condition. Then we move on to expandable launch vehicle. It is used in the only Europe and USA activities. Now India we have to use the space transportation vehicle. By this transportation vehicle we send the satellite to the initial orbit, then it move on to the destination orbit. This condition is called Huffman's orbit. This condition is called Huffman's orbit. Then we have to the satellite to be sent in the initial orbit, and it's running to move to the destination orbit. Then we have convert the a satellite having the condition of payload and the bus condition also. The payload is a transportation device which hold the devices to be transferred in the satellite, and it having the condition of thrust, mass and the acceleration also. Then we have to see in that what are the data we have to send. One is telephony signal. Next one is voice data. Third one is video. In the telephony signal, it is just a data to be transferred through the telephone. Thus, the voice data is having the data which should be transport the voice data also, and the video is nothing but a video data. We have to compress these data to transfer